Hi there, for those of you just tuning in, this is going to be a quantitative skills and reasoning review session for the final. So if you have any questions, there should be a chat box on the right hand side. I strongly encourage you to ask any questions that you might have in that chat box. And if you have some extra questions, if it's going to appear later, I'll just let you know about that. And if it's during a problem, please ask and I'll try and clarify any issues that we might be having. So without further ado, we'll go ahead and get started with a few problems. And once again, just keep on asking those questions in the chat box if you have them. So we have Al, Bo, Cy, Di, Ed, and Flo decide to race each other at a local 5K race. How many different possibilities exist for a first, second, third place finish among these 6 runners if there are no ties? So when you look at this, essentially you have 3 positions that we're only caring about. You have a first position, a second position, and a third position. Okay? And let's think about how many different possibilities would we have for that first position. Well, if you notice there's 6 runners, so that means there's 6 possibilities for first place. But if there are no ties, that means as soon as that first person finishes in first place, that means they can't finish in second place as well. So you're left with 1 less person, which means we have 5 there. And since this is steps to a sequence, you're talking multiplication principle. Is at least one approach here. We're going to talk about another approach that might be a little bit quicker. So then moving forward from there, what actually happens? Well, if you look at the third position, we've had a first and second place, so that means 2 people have been accounted for. So that means if we go 6 minus 4, that should be what appears here, which is 4 possibilities. And once again, this is steps to a sequence, so it's multiplication principle, and that's why we have that answer right there. So notice that makes 20 times 6, that's 120. But that's not the only approach here. Notice order was important because you had a first, second, and third place. And so we're talking order being important, and we have distinct people, and no repeats are allowed. So we have a permutation on, we have 6 elements in our set, and then so this will be a 3 permutation of those 6 elements because we have 3 positions to worry about. And if you recall, this equals 6 factorial over 6 minus 3 factorial, which, by the way, come test time P63, that does it. That'll do the trick for us. You don't have to go through all the calculations. I know you can punch that into a calculator if need be. But here, this is 6 factorial over 3 factorial. Now this does not become just good old 2 factorial. It's something different. Because 6 factorial stands for 6 times 5 times 4 times 3 times 2 times 1. And the denominator is just 3 times 2 times 1. And notice that 3 times 2 times 1 cancels. An easier way for us to have written this, though, is notice we could have written 3 times 2 times 1 as 3 factorial, and we could have just canceled that right away. So this is 6 times 5 times 4, and we have, once again, 120. So just a slightly different method, giving us the same result, though. Okay, so I don't see any questions on that one. I'll just keep on moving forward. So now we're going to, in a state lottery, 6 balls are chosen from a set of 70 balls, numbered 1 through 70. In how many ways can 6 balls be chosen? So notice here, if you had a lottery ticket or something of that sort, what are we actually looking at? Well, do we care what order our ball is actually selected? So if, say the number, say 7 and 11 were both on our lottery ticket. If they called 11 first, will we be happy? Oh yeah, we'd be happy. If they called 7 first, will we be happy? Oh yeah, we'd be happy. It doesn't matter on the order. So when we think about that, if it doesn't matter on the order is not important, but we do have distinct numbers. We're talking a combination. So with that in mind, we have a combination, and there's a couple different ways to write it. I'll use a C format. So C70, and then how many of those balls do we want to select? Well, it's going to be 6 of those. Another way you might see this written, this is the same thing as 70 to 6. You probably heard me say that as well. So both of those go hand in hand. They get the job done for us. So now, where do we go from here? Well, we have a nice little formula for combinations. You could leave it as that, that's fine with me. But just so we can see it worked out and try and give you some perspective on the lottery, this goes 70 minus 6 factorial, and then another 6 factorial. That's just our combination formula. And from here, what do? Well, down below we're going to have 64 factorial, 6 factorial. And we can do 70 times 69 times 68 times 67 times 66 times 65. And we could keep on going, 64, 63, 62, 61, all the way down to 1. But remember, we're just counting down from 64, and that would just be 64 factorial. And why did we stop there? Well, the 64 factorial is now canceled. And we're left with 70 times 69 times 68 times 67 times 66 times 65. All over 6 times 5 times 4 times 3 times 2 and times 1. Okay, so let's see here. Some of those things that we can cancel off with 3 and 2 make 6, so that'll cancel off with a 66 and give us 11. What else do we have? We have a 5 will go into the, we can do it in that either the 65 or the 70. So we'll take 5 into, say 65. What are we left with? Well, that should be 13, I believe. And where can 4 go into? 4 goes into 68. And that should be, I believe, 17 times, if I remember correctly. Doing that. And then where can we put 6? We have an extra 6 here. If we take, well, actually, I probably should have done it with the 66. So we can take, for example, take 2 out of that. And so that'll be left with 3. And so that makes this 35. And then where can the 3 go? Well, that can go into the 69 and leave us with 23, I believe. And so when all said and done, all we need to do now is just multiply 35 times 23 times 17 times 67 times 11 times 13. And for those of you wondering why am I going through all this, you could have done it right away. I'm just trying to show you to try and make it easier on a calculator for you. And you should finish with, it's going to be a really large number. So we have a 985 here, and 115, and we have 131. So 131,115,985. It seems like good odds to play the lottery, right? That's what's happening here, but let's actually put this in context. So this is not part of the problem. I just want you all to kind of realize what's going on here. So distance from Jacksonville to Savannah. You might have heard me say this before. The distance from Jacksonville to Savannah is approximately 140 miles. Now, let's put that into terms of inches. So 140 miles, and there's 5,280 feet per 1 mile. And there's 12 inches per 1 foot. If you actually multiply that out, so you take the 140 times 5,280 times the 12, what do we end up getting? Well, we get 8,870,400 inches. Now, why is that? What am I trying to get at? Well, so here's the deal, to kind of give you some perspective. Say you had this car. That's a beautiful car, don't want your eyes fool you. And you're going down the road from Savannah to Jacksonville. And let's say someone blindfolded you and had a stick somewhere along the way from Savannah to Jacksonville, but the stick is only 1 inch thick. And someone gave you a coin and said, hey, you know what, while you're driving, I want you to close your eyes and somewhere toss it out the window randomly. And I want you to hit that stick. Do you think you can hit that stick? Well, most people would say no. So what actually does that mean? The odds of actually hitting that stick somewhere along the line from Savannah to Jacksonville is actually better than the odds of winning the lottery. Yet people think it's great to play the lottery. So I just want to put that in perspective in terms of what's actually happening. Compare the numbers. That 131 million is a very, very large number. And so odds of winning are pretty slim. And I've always made the claim, if you ever win the lottery, come back, rub it in my face, do all that stuff. I'm happy. I'll be ecstatic for you. And that claim still holds for this class as well. So if you ever have that happen, go ahead and give me a shout out. So, moving forward from there, let's go to probability. So we want to consider the spinner given below. Assume that D takes up 1/3 of the area of the circle, and that the spinner is symmetric about the vertical line through the center. So find the probability of each sector. So we have 5 different sectors here. So we have A, B, C, D, and E. So I'm going to write probability of A, probability of B, probability of C, probability of D, and probability of E. Now remember, if we take the sum of all the probabilities, we should have the probability of the sample space, which should equal 1. So that's something to keep in mind here. And we have that D takes up 1/3 of the area in this case. So that means the probability of D equals 1/3. Now where do we go from here? Well, we see that there's a top half. A and B have broken the top half into a half, so that means the probability of A, well, half of a half is 1/4, and the probability of B is half of a half is 1/4. So now what that means is, if you think about it, probability of C plus probability of E plus the 1/3 from the probability of D, that has to equal 1/2. So notice the probability of C plus the probability of E, notice those are supposed to be equal and symmetric there. So we have, this is essentially probability of C plus probability of C equals, when you subtract the 1/3 from both sides, you get 1/2 minus 1/3. You can get a common denominator. That's 3/6 minus 2/6 equals 2 times the probability of C. And so that equals, if you notice, that'll be 1/6. But so that means if we divide both sides by 2, we get probability of C equals 1/6 divided by 2, which is the same thing as 1/6 times 2, which gives us 1/12. Remember, probability of E is the same thing, so this is 1/12, and that must be 1/12. So find the probability the pointer will stop in a sector labeled with a vowel. Well, let's think of our vowels. We have A, B is not, C is not, D is not, but E is. So A or E. Well, since those are disjoint events, we can actually break them up. There's a nice rule of probability. So you have probability of A plus the probability of E. And then what happens? Well, the probability of A, we already know, is 1/4. And the probability of E, we know, is 1/12. Now, if you want to make a common denominator, you can write this as 3/12 plus 1/12 equals 4/12. So that means our probability happens to be 1/3. Okay. So moving forward with those rules of probability, what's going on? So let's say we have a positive integer less than 100 is chosen. What's the probability that it is, we're going to start with not a multiple of 5. So when we're looking for the probability of not a multiple of 5, there might be an easier way to think about this. Now, if you were to list out all the numbers 1 to 100, because that's essentially what our playground is here, we'd have to start tossing in, for example, 1, 2, 3, 4. Then we skip 5 because it can't be a multiple of 5. Then 6, 7, 8, 9. skip 10 because that's a multiple of 5, and so on and so forth. Well, it might be easier for us to just count the multiples of 5, right? And so when you take a look at this, what are we getting? Well, another way for us to look at that is, from the rules of probability, is go 1 minus the opposite of n. So 1 minus the probability that it is a multiple of 5. And this will probably be a much easier task for us. And the reason why is, well, if you think, how many multiples of 5 are there in 100? Well, that's a nice calculation for us. We can take 100 divided by 25, well, not 25, 100 divided by 5, sorry, getting the 20, got ahead of myself there. 100 divided by 5, so this should be, oops, I should be careful here. Remember, it's a probability, so I have 100 divided by 5 over how many numbers? So it should be out of 100 numbers. So this is 1 minus, you get 20 over 100, which you can rewrite 20 over 100 as 1 out of 5. So 1 minus 1/5, which is the same thing as 5/5 minus 1/5, which equals 4/5. And by the way, if you want to write it as a decimal, feel free to. Just make sure you include a few decimal places if need be. And for our next problem, we're going to take another rule of probability and kind of put that to use. So you saw when two things are disjoint, in this case that's not going to happen. So for example, 10 is both a multiple of 5 or 2. So when we do these probabilities, you can do the multiple of 5, multiples of 5 for that probability, plus the multiple probability of the multiples of 2. But now we have to think of the probability of the multiples of both. Oops, says that 5 and 2. Because we've counted those twice. We counted them in the multiples of 5 and we counted them in the multiples of 2. So we need to get rid of that double count, and that's why we subtract that intersection out. So what does that mean now? Probability of multiples of 5. Well, we already found out that's 100 divided by 5 over 100. The multiples of 2, so 2, 4, 6, 8, 10, so on and so forth. Well, notice we should have 100 divided by 2 multiples of 2. And that's all divided by 100. And then we got to subtract out, what would be a multiple of both 5 and 10? Or 5 and 2. I'm sorry, I kind of gave away the answer there. If you have a multiple of 5 and it's a multiple of 2, notice it can't be an odd number because it's a multiple of 2. That means it must be a multiple of 10. And so this, an easier way for us to say both 5 and 2, multiples of 10. And so our easy way to calculate that is just 100 divided by 10, all over 100. And so all of this equals, we get 20. And we already have a common denominator right now, so I won't change that. 20 plus 50 minus 10. All over 100. And so what does that equal? Well, we're going to get 70 minus 10 is 60 over 100, which is 6 over 10 or 3 over 5. So hopefully that makes sense on the probabilities, using the rules especially, because you're going to be asked to do that here coming up soon. Now we'll move forward onto normal distributions, see what's going on there. So, looking at this, after recently taking the ACT, Joseph learned that the results follow a normal distribution with a mean score of 25 and a standard deviation of 3.7. If Joseph scores a 32 on the ACT, then he scored better than what percentage of students? So recall, a normal distribution, we have some sort of bell curve, and it's completely determined by its mean. So this mu in this case is 25. And then you can start adding on. So if we did 3.7 added on, that would be 28.7. And we can add another 3.7 on. And so I think that gives us right around 32.4. And so what happens is, in this case, we want to figure out this area appearing to the left of, say, 32. We'll say that's 32 right there. So in order to do that, though, we don't have a nice formula for this particular normal distribution. So what we need to do is use a standard normal distribution. And that's where we get this idea of a z-score. And if you recall, z equals this x, where x is our observation, minus our mu, where mu is our mean, divided by sigma. So in our case, x equals, well, it's going to be the observation, which is 32. Our mu is our mean, which states mean score of 25 right there. Our standard deviation is sigma, and that's 3.7. Z equals x minus mu divided by sigma. So we get 32 minus 25, all divided by 3.7. Now here's a little caveat. If you are punching that into the calculator and all that stuff, be careful. Make sure to put your numerator in parentheses. And if you ever have addition or subtraction in the denominator, make sure to put it in parentheses. So just get in the habit, put your numerator in parentheses, put your denominator in parentheses. That'll go a long way. So this is approximately equal to 1.89. So I'm going to make a quick jump in terms of the percentage. I have to look up a z-score of 1.89 in the table. So in order to do that, I actually already have it here. So we need to look for 1.89. So if you're looking for the 1.89, you can kind of see the scrolling going on right here, hopefully. And so notice we start at the 1.8 row. That's the z-score. And we kind of scroll on over until we get to 1.8, and then we have the 9 right there. Notice we have a 0.9706. Oops. Okay, so 0.9706 is actually what we got, and that will be our answer here. So what percentage? Well, so 0.9706 is the value, but turning that to a percentage is 97.06%. That's a pretty gosh darn good score on the ACT for 97.06%. So now in the other scenario, what score would Joseph need to be among the top 10% of students? So notice, we want to use the z equals x minus mu divided by sigma, but we want to use it in a different way. We're looking for the score. So we're looking for the x value. So we need to find z, which we'll do in a second, but on the other side we have x minus, we know mu has not changed, that's still 25. And then sigma, that's 3.7. Now, how can we figure out what is the corresponding z-score? Well, if this is the top 10%, what does that mean? That means 90% are below. So when we look at our table, we want to look for the thing closest to 90%. So 0.90. So whatever has 0.90 seems to be the closest. So if you're looking, we have a 0.9032 at 1.30, but you have a 0.9015 at 1.29, and then you have a 0.8997. That's really close to 0.90 at 1.28. And so you can approximate in between 1.28 and 1.29. Either one will work. I'd recommend just, you can do like maybe a 1.281 or 2 or something like that. But just to keep it simple, I'll say z is 1.28. So how do we go about figuring our value? Well, now it's just solving a nice linear equation. So first things first, you get rid of the 3.7 by multiplying both sides by 3.7. So you get 1.28 times 3.7 equals x minus 25. And now x equals, we add the 25 to both sides, so 25 plus 1.28 times 3.7. So what does that become? 25 plus 1.28 times 3.7. And so our x value equals 29.736. And that's our final answer. So you need a score of at least, and since they are whole numbers, last time I checked on the ACT, you need at least a 30 in order to get to that 90th percentile or top 10% of students. Okay, with no other questions, keep on trucking along here. So now let's look at mean, median, and mode. So we have the daily traffic recorded, the speed of the drivers passing through the intersection of Abercorn and Eisenhower and Savannah. Determine the mean, median, and mode if the data is displayed in the table below. The easiest of all these. Now, well, actually, first, before we even do that, for some reason, a lot of people struggle with this. What is it? What's the data points? Well, they're the miles per hour. They're not the number of drivers. They're miles per hour. What the number of drivers tells us is you start with 30, 30, 30, 30, 30. So there's 5 of these. Right? That's what happens, so 5 of these. In the next part, we're going to have 40, 40, and it's a whole bunch of 40s. At the end of the day, we should have 25 different 40s. Okay? And then you can keep on going. So we have 50, 50, 50. I can write this one out because there's only 6 of them. And then finally 70, 70, 70, 70. Okay? So there's 6 50s and 4 70s. So now you could do these one by one, but it's a lot easier to just use some properties we know. First off, the mode. That should be easy. And all you're doing is looking at what has the most number of drivers. So that's going to be 25. So there's 25 drivers, and then what's the speed that we're looking for? Well, it's going to be, the mode is 40 miles per hour. Right? A lot of people will put the 25 down. The 25 is indicating how many times the 40 occurs. Just remember that. So now for the median, we got to first find the location of the median. And the way to do that is you take the number of observations plus 1 divided by 2, and it should occur in that location. Well, if you notice, we have 30, 40 drivers. That's the number of observations. So you take 40 plus 1 divided by 2. So this should occur at the 20.5 position. Well, notice if we have 25 40s, so you have 2 things that you're going to look for. You're going to look for the 20th position and the 21st. Now, in this case, they're both the same number. So it's not going to be much to it, but so just to kind of give you a general idea as to what would happen, the median will be, you take 40 plus the other number, right? Well, in this case, it's 40, and you divide that by 2. You take the average of those 2 values. And so our answer is 40 miles per hour again. So we kind of lucked out and got the same value. Now, the mean, what does that equal? Well, remember, we have to divide by the number of observations, which in this case we just found is 40. So you could add up 30, 30, 30, 30, 30. The easy way for us to write that is 30 times 5 plus, you'll notice it's 40 times 25, right, because there's 25 of those 40s, plus 50 times 6, because there's 6 of the 50s, and plus 70 times 4. Okay. Remember, when doing this, put your whole numerator in parentheses. So just be careful on that. That's actually the biggest mistake, to be honest with you. But I see problems like this. So 70 times 4. And so that's 150 plus 1,000. 25 plus another 300 plus another 280. And so when you divide all this by 40, you get an answer of 43.35. And this should be, by the way, miles per hour. So now we kind of have all those pieces in place. Let's take a look at our next problem. Percentages, all right. So let's take a look at these. This tends to be a struggle, so I want to make sure we have it down for the time for our final. So Rose's recent Amazon order came to $59.74. If she paid a 7% sales tax, then how much did the order cost before tax? So let's call X the before tax amount. A lot of people freak out with X, but don't let that fool you. So we have X plus we have that extra 7% sales tax on X, right? So 7%. And that should equal $59.74. Right? So on top of this, what happens? Well, notice you actually have 1X. Right? You talk about how you can find the answer. You always take 1.07 times X equals 59.74. So the way to solve for X is just divide both sides by 1.07. So you have 59.74 divided by 1.07. So what does that equal? We might have to do some rounding since we're talking dollars and cents here. So 59.74 divided by 1.07. That gives us $55 approximately and 83 cents. And so that was our original cost. Now, just an FYI, so what is the total tax? How would we get that? Well, you can take the $59.74 and you subtract off the $55.83. Right? If you take 59.74 minus 55.83, you're left with $3.91 for that sales tax. So just showing you how you can solve for those. Now, similar manner, enrollment at Georgia Southern increased by 9.6% to 17,000 students in spring 2017. How many students were enrolled during the previous semester? So if they increased by 9.6%, notice we start with X, and I'll just say fall semester enrollment. And you see these percentages happen a lot. So you can write X plus, and then we've increased X by 0.096. Right? And that should equal 17,000. So notice another way to write this is 1.096x, and that's because it's a percent increase. You kind of see those in the homework assignments and things of that nature, or I should say quizzes. So what we can do now is divide both sides by our 1.096. So if we take x equal to 17,000 over 1.096, what do we get? Well, we get approximately, and since we have students is what we're talking about, we want to round to the nearest student. So 15,511 students. So that trips up a lot of people. Most times I'll see people just multiply that amount, the 17,000, by the 0.096. You have to pay attention to when we're talking increase or decrease from a previous time. So how many students enrolled during the previous semester, right? Think about, are we talking before or after this percent increase or decrease? So are we working with a number that's the finished product, or the number that we're going to take the percentage out? So keep that in mind on those problems. All right, investing formulas. So this can trip people up a lot of times. So I'm going to kind of list what goes on with all these investing formulas. There's a ton of them. So the compound interest formula, I have an AFT. If you learn function format, that's essentially what this is. Compound interest formula, you get A equals P times 1 plus R over N raised to the NT. What P stands for is principal, investment. R stands for annual interest rate. There's a decimal. N is the number of times compounding per year. T is the time in years. And A is the final amount after T years. Okay, when do we use a compound interest formula? Well, where you have fixed intervals where this is investments being compounded. So say something like compounded quarterly, compounded monthly, things like that. And then the P is a single initial investment. So there's another idea of the savings plan formula. That's where you're having multiple investments going on. So compounded continuously, similar manner, you have the PA equals PE, the RT. RT, P, and A all stand for the same thing. And what is E? It's a number. So just like when you think pi is 3.14159, E is 2.718, so on and so forth, 28, and you can go so on and so forth. But you have a number in your calculator that does it for you. So keep that in mind. So when do we have that? Well, you'll have things that are compounded continuously. It'll say continuously compounded or things of that nature. Unless you have, say, a radioactive decay. In that case, you're also talking, because you're having something that's compounding continuously when it's decaying. It doesn't just say, oh, I'm going to decay today, but definitely not decay tomorrow. So it's continuously decaying. So keep that in mind for those formulas. Now, for the savings plan formula, this one gets a little more complicated. So you have P times, you get a 1 plus R over N raised to the nt power minus 1 all divided by R over N. Now, the R and the N and the T all stand for the same thing, along with the one difference is the P now becomes a P with a subscript M. And the PM stands for the regular deposit amount. So in the final one, for our loan payment formula, so savings plan, how do you distinguish between a savings plan formula and compound interest formula? You're making regular deposit amounts. So for example, the first one has only one deposit amount. The third one has some, it's like a monthly contribution or a bi-weekly contribution. Take every paycheck when you're making that contribution. That's what you're kind of looking for. So last but certainly not least, I'm going to abuse some notation here too. We have this. So R's and N's are the same. But here, the P stands for the original loan amount, because we're talking loan payment formula. So we're taking money out and we're paying it back. And then notice we saw for this piece of M, that's the regular payment amount in this case. Okay, so we have all the components that we need. We're ready to get rocking and rolling and see what we can do here. So let's put these things to use. Jared starts making regular monthly deposits into his 401k at age 23. He continues to deposit $400 every month until he retires at age 67. Jared earns an annual interest rate of 7%. How much money will he have in his 401k when he retires? This is an important question that you're going to be faced with. You're going to have opportunities to contribute to 401ks, hopefully IRAs, things of that nature. I want to show you the impact of making those monthly deposits. Now, $400 every month may sound like a lot of money right now, but when you think about it, you start to think that's $4,800 a year. And hopefully, if you come out of college, you're making pretty decent money, and that isn't even, you know, it's not a big chunk of change in terms of the percent. You're not talking 20% even, hopefully, of your original job. So let's see what happens. So we're making regular monthly deposits. What does that tell us? Well, if we're using anything here, it has to be the savings plan formula. Okay? So we want to use that savings plan formula. So let's recall, what does that look like? That's A equals our regular monthly deposit amount, and then we have 1 plus R divided by N raised to NT minus 1 all over R divided by N. So now we need some information. Okay? And so let's see, what seems to be the easiest? Well, P with the subscript M, what's a regular deposit amount? That's $400. Okay, so that's not so bad. Notice it is monthly deposits, so in this case we're going to be talking N equals 12 because it's 12 times per year. What else do we have? R. Now, you might wonder, what kind of return can you expect? The S&P 500 is basically it's an aggregate. It's 500 of the most popular companies. Well, I shouldn't say popular, but 500 companies that kind of measure how the stock market's performing. And you have seen, if you've invested over time, the average rate of return of that S&P 500 is around 7%. Now, that does not mean every year it's going to be 7%. Oh, some years it's down 20, 30%. Some years it's up, 20%. So you really don't know what's going to happen. We can look at historically, it's been around 7%. Doesn't mean it will be in the future, but just gives you an idea as to what kind of returns have been in most cases. So that's more a realistic scenario. Now, the real question here is, what is time for Jared here? So Jared retires at 67, and then he started at 23. So you take 67 minus 23. Notice we have 44 years of working. Okay. So now we're ready to rock and roll. A equals is $400 times 1 plus R over N. So you have 0.07 divided by 12. Raised to the 12, and then 44 up top here. That's a 4. And that's another 4. Minus 1. All divided by 0.07 divided by 12. Now I want to give some warnings here. You're going to have to put all your numerator in parentheses. That's not the only warning. You want your exponent in parentheses as well. That's probably the most forgotten part, is people forget to put the exponent in parentheses, because what happens is, if you don't put it all in parentheses, when you just kind of raise it to the power, it'll just go to the power of 12, and then the 44 will become multiplied because of order of operations. So that's really what you have to watch out for, is those order of operations. That's the tricky part for a lot of those. So when we do all this, and we multiply after you get the whole fraction, and I'd recommend doing the fraction first and then multiplying by the 400. How much money do we finish up with? Well, hopefully this won't be too much of a shock to the system. You would be a millionaire. You'd have $1,410,000, $410,141, and just in case you want those extra cents, 59 cents. So just making those $400 over time, it can make a big difference. Now, just an FYI, how much did Jared put in? Because he didn't just toss in $1 million. Let's figure out. He did put in a lot of money, right? Because he did $400 per month times, and then we have 12 months for 1 year, and then we want to figure out over how many years. So for his career, we're talking 44 years for a career. Okay? So now when you do that, you have what is that? 4,800 times 44. So this little side note, might seem like Jared put in a lot of money, right? And $211,000 is a lot of money over time. But look, that $211,200 grew to $1.4 million. I'd take that investment every day of the week. And the biggest thing that Jared has on the side is time. And that's what I'm hoping a lot of you have. So when it comes to your own investing choices, you can make the right decision and try and invest. Give it time, let it grow, things of that nature. So just giving you a little FYI in terms of what's happening when it comes to investments. Compounding, the length of time you're investing with it compounding, the bigger the difference is. So last but not least, we have a mortgage scenario. So Deborah decides to take out a 30-year mortgage to pay $250,000 towards the home. The annual interest rate for the mortgage is 4.25%, and how much interest will Deborah pay? And then one thing with a mortgage, I didn't write that here, but usually what happens, these are monthly payments. And since we are paying out, we need to use the loan payment formula. Okay. If that's the case, what happens? If you're using the loan payment formula, we have our regular payment amount equals, we've got to take our principal, and it goes R divided by N over 1 minus 1 plus R over N raised to the negative NT. Just to double check and make sure, I hope I wrote that on the first page. Sometimes I forget. No, I have the negative NT. So we're good. Just making sure if you were taking notes that we all have the same stuff. So in terms of this, now we need to figure out what is P? What is that amount that we're taking out? Well, it's $250,000. Okay, what is R? Well, R is going to be the 0.0425. Okay, for 4.25%. If it's a monthly payment, our N has to equal 12. And then what is T? Well, notice T says 30 years. This is a 30-year mortgage. This is a very realistic scenario for a lot of people. Now, taking a look at what happens, we'll find that monthly payment amount. So you take $250,000. Then we have R divided by N, so that's 0.0425 divided by 12. Then we have 1 minus 1 plus 0.0425 divided by 12. Raised to the negative 12, and then we have a T, which is 30 years. There we go. Now moving forward from here, what happens? Well, once again, I recommend doing the stuff in the fraction first, and we'll figure out what this value comes approximately to the nearest cent. So the way I actually always do it is try and actually work with the denominator and save that answer. Not saying you have to do that whatsoever, but also make sure the exponent appearing in the denominator, you really have to be careful on that. Make sure it's in parentheses. So that's actually quite important. We have a negative 360 essentially sitting right there. So we're doing all this out. And finally get to our answer. Our monthly payment is $1,229.85 per month. Now, let's think about this. How much are we paying over the life of the loan? So we have $1,229.85. That is per 1 month. There is 12 months in 1 year. And there's 30 years for the one mortgage. Okay. And this should tell us how much we've paid over the life of that mortgage. So at the end of the day, you end up paying $442,746. Now, what does that mean on interest? when we take that 442,746, what are we subtracting off? Well, the original amount of the loan was 250,000. So minus 250,000. And notice our answer equals 192,746. Notice that's almost as much as the original mortgage. And that's why, just like time to work on our side, or 401ks and things of that nature, when you hear 30-year mortgages and things like that, yes, the payment might be lower than, say, a 15-year mortgage, but you will pay a lot more in interest over the life of the loan. So I just want you to be aware of that stuff going on there, what's happening in all these finances. So I don't see any questions popping up, so hopefully if you do have any questions, just feel free to email me, let me know what's going on. I wish you all the best of luck on the final, and have a good rest of the semester.